Okay, in this lesson we'll be relating scale drawings to ratio and rate, and this will be the last, our home stretch of our topic on ratio and proportional relationships. It all has to do with geometry and to scale drawings. So our introduction activity, guess what is pictured in the two pictures there, and then identify whether it is a reduction or enlargement of the original image. The purpose of this activity is for us to get an understanding of the terms reduction and enlargement. The scale drawings produced in grade 7 will focus on creating a scale drawing from a two-dimensional picture. So the first one is a picture of a subway map. Was a cropped photo that was just seen a reduction or an enlargement of the original picture below? How do you know? Well, it is a reduction since it is scaled down picture of a map of a subway. If you compare the length of one end of the track to the other end, you can see that the cropped photo has a shorter length as compared to the original photo. Any corresponding length could be compared. And here it is. So we have this and the original here. So the second one is a picture of a fingerprint, and was a cropped photo that was just seen a reduction or an enlargement of the original picture below. And how do you know? Well, it is an enlargement since it was from a picture of a fingerprint. If you compare the actual one of the swirls to the actual fingerprint picture, you can see that the cropped photo has a longer length compared to the original fingerprint picture. Plus, you can look at your own fingers and know that the picture is bigger than a regular finger. And here they are. So this is the original fingerprint, and here is an enlargement. For each of the scale drawings, you identify if it is a reduction or enlargement to the actual object in real life or the given original picture. So for example 1, go ahead and answer those questions and then continue the video. Okay, for example 1, you should have had that from A to B is an enlargement if A is the actual picture. And from 2A to 2B, if this is the actual, then this would be a reduction. So what are possible uses for enlarged drawings or pictures? Well, enlarged drawings are good to observe details such as textures and parts that are hard to see with the naked eye. In art, enlargements are used in murals or portraits. So the big pictures you see splashed across a wall would normally be an enlargement of another picture or mural. So what are the possible purposes of reduced drawings or pictures? Well, reductions are purposeful to get the general idea of a picture or object. These scale drawings can fit in a folder, book, a wallet, or anything else. So read and include in your math journal the key idea on scale drawings. So on the lesson worksheet, go ahead and include just the key ideas on scale drawings in your math journal and then continue the video. All right, so let's take a look at example 2, complete example 2 before continuing the video. So answer that question and then continue. All right, for example 2, you should have something that looks like this. Notice that if you compare the first drawing to the second one, some key landmark figures that stand out is this looks like a D, kind of, and this looks like a backwards D that is also, instead of being on top, it's on the bottom. So what this is it's actually a reflection and a reflection or a rotation, whichever you want to call it, but it is a flip and then a flip again. So it's a little interesting where you have to match up maybe this short line with the point R is going to match up with the short line here with point A on it. All right, so why doesn't point V correspond with point R? Well, although both points are at the bottom right-hand corner, they are positioned on two different ends of the path. Point V only corresponds to point W. What must be considered before identifying corresponding points? Well, we have to make sure we're looking at the maps in the same direction. Then we can see that it is a one-to-one correspondence because they are scale drawings of each other, and each point corresponds with one specific point on the other map. All right, go ahead and try exercise 1, and then continue the video when you are done. All right, for exercise 1, let's look at some questions first. The size of the units on the grid are enlarged and then reduced to produce two different scale drawings with lengths that are proportional to one another. Notice that the number of units of length is staying the same, but the size of each unit changes from one drawing to another due to the shrinking and enlarging of the grid. This allows for us to create a scale drawing without having to complete the computation required in finding equivalent ratios, which we're going to be doing quite a bit in the rest of our topic D. So how will we make an enlarged robot? Well, we need to adjust the number of units. Well, no, again, because the grid is enlarged, thus changing the size of each unit, we can draw the new robot using the same number of units for each given length. So what is the importance of matching corresponding points and figures from actual picture to the scale drawing or the mural piece? Well, a scale drawing will not be proportional and the picture will look distorted, either stretched or short and squat or tall and thin. So how can you check the accuracy of the proportions? Well, you can count the squares and check that the points match. So here's what you could have had for your nesting robots. Notice that each square is different on the for the grid. These are very small squares that make up the grid. These are more medium-sized squares that make up the grid, and these are larger. So the reason that the smaller robot looks a little bit bigger and then quite big is because the grid squares are different, not because we've counted different lengths. So here is for the leg here, there's a width of 3. There's also a width of 3 and a width of 3 here. All right, example 3. Go ahead and try that and then continue the video when you are done. All right, for example 3, it says we want to record important points under the notes section of your lesson worksheet. Is the second image a reduction or enlargement of the first image, and how do you know? Well, it is a reduction because the second image is smaller than the first, which is the original image. So what do you notice about the information on the table? Well, the pairs of corresponding lengths are all proportional. Does a constant of proportionality exist, and how do you know this? Well, yes, it does, because there's a constant value to get from each length to its corresponding length on the other picture. So what is the constant of proportionality, and why is it important in scale drawings? Well, the constant of proportionality between the length and the height is 1/3, and it needs to exist for images to be considered scale drawings. If not, then there would be a lack of proportionality and the images would not be scaled up or down version of the original image. And again, they'll either look short and kind of squat, or it will be tall and thin, but it wouldn't look completely the same as the original image. So here are the pictures. Again, if we have a 18 to 6, and they said between the length and height, well, yes, so the length is 6 and the height is 18, so that would be 6 over 18 or 1/3. Same thing, 3 over 9 is 1/3. So that's where they're using constant of proportionality as 1/3. And the same thing here, they just put it in the table. Alright, so for exercise 2, fill out the table and answer the questions. Pay attention to the vertical and horizontal lengths of the legs. When you're done with that, go ahead and continue the video. Alright, you should have exercise 2 done, and this is what you should have. So on this triangle, we're not worrying about what is called the hypotenuse. We're just worried about the height and the length. So in this case, it is 5 to 15. Okay, so the length of the original image and the length of the second image. So if this is 5 and this is 15, and then the other one here is 3 to 10. So does a constant of proportionality exist? No, because the corresponding sides are not the same. So 15 to 5 is not the same as 3 to 10. Or even if you went this way, 5/3 or 5 to 3 is not the same as 15 to 10. You'd have a different proportionality. So is it a scale image? No, the enlarged mosaic image is not to scale. We know this because the images do not have side lengths that are proportional to each other, and therefore there's no constant of proportionality. Why is it difficult to determine if the second image is a reduction or enlargement of the first image? Well, the second image is not a scaled drawing of the first image, so even though it is bigger, it is not a true reduction or enlargement of the first image. So what must one check before determining if one image is a scaled drawing of another? Well, again, you want to check the corresponding lengths. They all need to be proportional to each other. If only one pair is proportional and the other is not, then the images cannot be identified as scaled drawings of one another. All right, so to wrap up, what is a scaled drawing? Well, it is a drawing that is a reduction or enlargement of an actual picture. And what is an enlargement? What is a reduction? Well, a drawing that is larger in scale than its original picture, or a drawing that is smaller in scale than its original picture. So what is the importance of matching points and figures from one picture or drawing to the next? Well, the corresponding lines, points, and figures need to match because otherwise the scaled drawing will be distorted and not proportional throughout. How do scale drawings relate to rates and ratios? Well, the corresponding lengths between scale drawings and original images are all equivalent ratios. All right, we'll see you in class.